Welcome. In this one, let's take a look at some derivatives or partial derivatives of products. So I'm going to say the partial with respect to x of x and then times sine of y. So like a level 1 example relative to the things it could be. Okay, so this is red, and now also we'll make this red. Now notice the sine y part that does not contain x anywhere. So I'll make that green. Because it doesn't contain x, the green part that is, you can place that outside the differentiation operation and you end up with sine of y like that. And then what's left after that is the derivative of x to the first, essentially. And then with respect to x, you see how those x parts are the same? So that means you got to leave that. You cannot take this x to the first out of the differentiation symbol. So then you have sine of y, and then you differentiate by the power rule. So it becomes 1x raised to the 1 minus 1. So the red part is the power rule that you've seen before, I'm sure. Okay, in lower level classes like Calculus 1. Then you finish this up, so you're going to have sine of y. I'm going to make that black now. And this is 1x raised to the 0. So the 0 up here. Anything to the 0 is 1, so you have sine of y, and then 1 times 1 for that reason. Right, this part here is like this part here. The green x to the 0 becomes the green 1 right here. And then you have sine of y. Now 1 times 1 is 1, so you can write that. And then you have sine of y times 1, which is sine of y. Okay, so this is an example done in great depth. I hope it's helpful. Okay, now let's look at a variation. Okay, so derivative with respect to xa of x squared and then sine of y. But now let's differentiate with respect to y. So now again, this is y, our differentiation variable. And notice where the y is. The y is now wrapped inside the sine, and the x squared here is separate, and this is multiplication right there between them. So for that reason, what you can do is pull the x squared out this way. Okay, because it's multiplying sine of y. So pull it out. And then what's left over is a derivative with respect to y of sine of y, like that. Okay, and then y is again here in the bottom. So just keep a careful eye on y right here, see? For this reason, because y is our differentiation variable, you can not just place the sine of y outside the differentiation operation. It doesn't work like that. You can actually differentiate. So you're going to have x squared. Now the derivative of sine y is just cosine y. That's really the whole step if you think about it. But now we just clean this up, so often we just write x squared cosine y or something along those lines, and that's the derivative. Okay, let's look at the next one, another variation of this. So now let's do y, say cubed, and then plus x sine y. So again, a slight variation. And let's do differentiation here. Let's see, with respect to x maybe. So this is x here, this is x here, right here. So notice that the y squared part here does not have x in it. So that means this should be seen like a constant, as if it said 5 or 10 or 90 or -8, some number. Okay, the sine y part again, that is to be seen like a constant with respect to x. So as this one, we can distribute the differentiation operation. So you're going to have y cubed. Now this y cubed, I'll make green. Okay, now the bottom differentiation variable is x. So that's important to understand because look, y cubed here does not have any x's in it. That means the y cubed is to be treated like a constant with respect to x, like a number like 5 or 10 or 90 or whatever. Plus, in the partial with respect to x, I'll put the x in here in red, x sine of y. So this part again, the sine of y part, I'll make that green. That does not have x in it. X, however, is present in this position. So when you differentiate, what do you get? Go to the next line. When you do this part, the derivative of y cubed with respect to x is just 0. Because the y cubed is to be seen as a constant, and constants have a derivative of 0, they do not change. But now the other part, what you can allows you to do is you can pull that sine y out this way, and just multiply by the derivative of that x, which is really like x to the first, recall over x, like this. So this is an x, and there's an x over here, like that also. So now you simplify. So we have sine of y, again, this is green, and then use a power rule. So 1 down x raised to the 1 minus 1. And then you simplify this sine of y, and then so 1x raised to the 0, if I wanted to be really careful, and then let me pull this up. Sine of y, and this is now 1 times 1 because x to 0 is 1. So you have sine of y times 1, but that's just sine of y. So you see the result here is the sine of y that we begin with in this position where it says x sine of y. Okay, so here's all of our work. This is the first example that I did in great detail. Hope it's helpful. So please be sure to leave a like, subscribe, and share, especially with the people who might find this useful to them because they're studying math or whatever. right? This is the second example, x squared times sine y, so it becomes x squared cosine y. And here's the third example, the most extensive, so I'm going to maybe make it smaller. And you can see it though now from top to bottom. Leave a like if it's helpful, friends. Please be sure to subscribe and share.